So now I will continue on the control valve characteristic. Okay, basically what we need to consider is the CV coefficient or flow coefficient of a control valve. So basically this CV or flow coefficient will depend on the valve positions. So the CV is varies from 0. So when the CV is 0, the valve is closed and the valve position also is equal to 0. So if CV equal to max, that means the valve is fully open. So the variation of the CV allow the valve to continuously regulate the flow. So particularly function relating to CV coefficient to the valve is known as a valve characteristic. So we have three types of valve characteristic, which is quick opening, linear, and equal percentage. Okay. So we can see from this figure, okay, we have three different type of characteristic. So normally the difference is at the seat structure. You can see for the fast opening, the structure is the plug is slightly wide, and for the linear, normally the plug is slightly curved. And for the equal percentage, we can see the plug, the design of the plug is quite curved, and there is a the straight area at the bottom of the plug. Okay, so this kind of plug will use for different process, and each of the plug have a different characteristic. Okay, basically this figure is a figure of percent of full flow at constant pressure versus percent of full valve steam travel. So basically at the bottom one is a valve position, at the y-axis is a CV. So we can see from the graph, the linear graph is referring to the linear valve characteristic. For the curve, the upward curve is a quick opening, and downward curve is equal percentage. Okay, so for the y-axis, just now I mentioned is for the CV value, right? So basically the CV value is determined based on the flow coefficient is at the bottom of the valve. For the valve position is depend on of this movement of the spring that relate to the steam. So okay, we can see from here, for the air to open valve, normally it's operate between 3 psig to 15 psig. That means we feed in the air from the valve will operate from 3 psig until 15. For the air to close valve, it is inverse to the air to open, because we need to, in order to close the valve, we need to feed in the air. Okay, so at here we can know the amount of flow produced with respect to the steady increment in stem travel. The stem will travel whether upward or downward based on the amount of the flow inside here. For the first valve characteristic, which is quick opening, normally it's not suitable for regulating the flow because the variation of the valve coefficient take place in the lower third of the valve level. So basically the linear and equal percentage lah. For the quick opening, it's fall at the upper level of the valve level. So when the valve, in the quick opening valve, the variation in coefficient is very little for most of valve travel. So this quick opening most likely been used for the relief valve and also on-off control system. So relief valve is one of the type of the valve that been used inside the, not inside, at the tank system. For example, if the tank is operate higher than the optimal limits, so this relief valve will function by releasing the pressure, the accumulated pressure inside the valve, inside the tank. So it want to avoid any overpressure occur inside the tank. Okay, so like what I mentioned before, for the function to regulate the flow, normally we will use linear and equal percentage valve. Okay, for the linear characteristic valve, the coefficient of the valve, coefficient of the flow will be equal to the maximum flow coefficients. It depends on the valve position. So basically the flow coefficient, which is CV, is proportional to the valve position. CV and VP will be proportional. You can see from the graph, the linear graph, it shows that the value of CV at the y-axis is proportional to the value of VP at the x-axis. So this linear characteristic valve will be used in a linear process, and the pressure drop across the valve do not vary with flow. If the valve position is 50%, the value of CV would be 50% also. It shows the proportional relationship. For the equal percentage, the function for equal percentage characteristic, normally the flow coefficient would be equal to the flow coefficient, maximum flow coefficient time with the rangeability parameter. So normally the rangeability parameter is between 50 or 100. So this, because of this valve consider rangeability, this one basically produce an exponential function to the valve opening. So it results in equal relative or percentage increment. So you can see from the graph, right? The graph is curved downward. The graph that I show you just now. It shows the exponential shape. Okay, basically this equal percentage valve is used when the pressure drop across the valve do not vary with flow, and with the process which decrease when the flow through the valve increase. Okay, for the exponential function, it has a property that equal increment in valve position. So it results in an equal relative or percentage increment in the valve coefficient. When we increase the valve position by 1%, the flow increase by 1% also. The increment of the valve positions, the relationship between the valve position and also the flow coefficient is in terms of percentage. Okay, now let's try to do the example. So now we have this graph. So basically the y-axis is for CV, the x-axis for VP. Okay, now what will be the flow rate when the indicator shows 0.75? And that means the position of the valve is 0.75 is equivalent to 75%. So you may drag the line here from 75%. Okay. So for quick opening, okay, the value of 75% give the flow coefficient, which is CV, is around 95%. So for 95%, we can see that the flow rate is around 7.8 gallon per minute. You just track the line and then you can get 95, and this is the scale for the this one is the scale, this one is the scale for the flow rate. So 95% is likely here around 7.8 gallon per minute. Okay, for the linear, so for the linear, like what I'm saying before, the valve position should directly proportional to the flow coefficient. So that means the flow coefficient will get 75%. So you may drag the line, and yes, you can get 75% around 6 gallon per meter. For the equal percentage, so slightly here, the flow coefficient is 30%. The flow rate is around 2.3 gallon per minute. Okay. Now we move. Okay. For the valve, we also need to consider the valve rangeability. So this rangeability is also called turn down ratio. The ratio is the ratio of the maximum controllable flow to the minimum controllable flow. So this valve rangeability measures the width of operating flow the valve can control. So normally the valve will not operate 0% to 100%. The maximum and minimum flow would be 5% to 95%. The maximum and minimum flow at 95 and 5% valve position. So basically, reachability, you need to divide the flow at 95% valve position over flow at 5% valve position. Sometimes there is a valve that can operate from 10% to 90%. So if you want to calculate the rangeability, you need to find the flow at 10% divided with the flow at 90%. It depends on the type of the valve that you will use later on. So the common one is this one. Okay, so if the pressure drop across the valve is independent of the flow, so the flow through the valve is proportional to its CV. We can calculate the valve rangeability from its inherent characteristic, which is from this formula just now. So basically for the linear characteristic, the rangeability is directly proportional, right? So we can directly divide 0.95 over 0.05. So we can get 19. For the equal percentage characteristic, we need to depend on the exponential function. So we need to divide the exponential for 5% over exponential for 95%. So we can get this value. So like what I mentioned before, the A value can be 50 or 100. So the rangeability would have two different values also. For the 50 is 33.8, for 100 is 63.1. So for the quick opening characteristic, the rangeability is fixed, which is 3. This is the small range. Okay, when you get the question about the rangeability, you may use this formula, and for the quick opening, you can directly take the given value. Okay, so this is the end of the slide. Okay, we will see. I will see you back uh, in the live class for the topic 5. Okay, thank you.